This is activity 3, same perimeter. In the last activity, we looked at all the same, meaning that all the y coordinates were the same along a line, or all the x coordinates were the same along a line. In this case, we're going to look at a bunch of different rectangles that all have the same perimeter. What does the equation for a line look like that describes those rectangles? And that same perimeter is going to be 50 units. Now, if you look at this table as a rectangle, it has two lengths. Here's the length along the top and the length along the bottom, and it has two widths. This width along the right side here and this width along the left side. And so if you add all those four lengths together, they're always going to equal 50 units in these series of rectangles that we're going to draw. So how do you figure out what are different lengths and different widths of those rectangles? Well, you can start off with saying, I'm going to call this length along the top 25 units. That means that you've used up 25 units along the top and 25 units along the bottom. So you've used up your 50 units. You don't have anything left for the width. So that means the width is 0. So this is just a line that's 25 units long. But now what if I say, I'm going to use a length of 24 units? Well, you're going to use up 48 units of the perimeter as the length. So it's 2 times that 24 is going to be 48. You're going to have 2 units left over, and those 2 units have to be cut in half. So 1 unit for the width and 1 unit for the other width. All right, so moving to 20 units for the length. Now you're going to use up 40. You're going to double that length. You're going to use up 40 units of your total 50 units. So I'm doubling the length right here, and I'm going to subtract that from 50. So that tells me I have 10 units left. So 2 times the width equals 10 units. That means the width then equals half of that 10, or 5 units. And if I use up 15 units on a length, I'm going to double that length to 30. Going to subtract that from 15. That's going to leave me 20 units, and half of those 20 units are going to be 10 units for each width. And by now you might start to realize that you can just work with the 25. You can cut everything in half. And so I have, if I look at one of the widths and one of the lengths, that's going to total 25 units. So if I use up 24 of those units for the length, that means I have 1 unit left for the width. If I use up 20 units of the length, that means I have 5 units left for the width, or 15 units for the length means I have 10 units left for the width. So now I'm just looking at half of the total length and half of the total width. And so if I continue that, if I choose 13 units for the length, that leaves 12 units for the width. So again, that means 13 units along one length, 13 units along another length. So that leaves me with 12 units along one width and 12 units along the other width. So the total perimeter is still 50, but I only have to work with half of that perimeter because both lengths are the same length and both widths are the same length. They're the same measure, to not confuse you. All right, so length of 12 units. That means I have 13 units left for the width. So now the width is going to be longer than the length. If I use 12.5 units, this is a special case of a square. So both the length and the width are 12.5 units. So what I've started to do is use this equation. So I'm going to choose a value for the length, let's say 5 units. And I'm going to subtract those 5 units from 25 because I have 25 units of the perimeter to work with. Half of the perimeter, half of 50 is that 25. So I'm going to choose 5 units to use for the length. That leaves me 20 units for the width. So I'm just subtracting the length from the width. And so if you look at this little drawing here, I'm taking a portion of the length and I'm adding it to the width. So I'm subtracting, if I subtract a portion of this length here, I can add it to this width so that these two measures of the rectangle always add to 25 units. So that's fixed. They always have to add to 25. So you can take part of the length away, add it to the width, or you can take part of the width away and add it to the length as long as they always add to 25 units. So I ended up using this equation to do the calculation. I didn't really use an equation. You just calculate in your head. You know what you're doing. You have 25 units. You take away 10 units. That leaves 15 units, and so on. Now you can work with that equation. If I call the length y and the width x, then I can get this to the form of y equals mx plus b, just with a little bit of algebra here. So if you subtract the length, that's the same as adding the opposite of the length, the opposite sign or the opposite value of the length. So subtracting a positive length is the same as adding a negative length. Well, that negative length, that's the opposite of the length. So that's a -1 times this length. It's the opposite of that length. And I can switch these. I want to get it to y equals mx plus b. So I can move these and switch places using the commutative property of addition. So I can use this -1 times the length, or the opposite of the measure of the length, move that here and move the 25 here. So now it's in this form of y equals mx plus b. And the slope is -1. And where it crosses the y-intercept is 25. Notice that's half of the total perimeter. And the slope -1 means whatever change I make to the length, I'm going to make the opposite change, an equal amount, but the opposite change to the width. So if I subtract a value, a portion of the length, if I make that change, I'm going to add that same value to the width. You're going to see in a moment that that ends up being a slope of -1. All right, so here's a drawing of each of those rectangles on a grid. So the perimeters all add to a total of 50 units, and half the perimeter adds to this total of 25 units. And if you look at that equation, go back for just a second. Actually, this equation right here, well, let's work with the slope first. If you figure out the slope of this line, so you want to figure out what the equation for this line is. So what I'm doing is connecting all the points of the vertex that is in the upper right corner. Turns out they all lie on this line, and the slope of that line, you can just count. Choose this point here and this point here. So this is a +7 units. So that change is a +7 units in the width. So you're going to add 7 units to the width, and it's a -7 units in the length. So you're going to subtract 7 units from the length. So you're going to end up with, you're going to move from this rectangle. So you're going to add 7 units to the width, subtract 7 units from the length, and you're going to end up with this rectangle down here. Wish I had made it a different color. Right, but that slope is, remember, it's the change in the amount of the, along the y-axis divided by or over the change along the x-axis. So this is a -7 over a +7. So a -7 over a +7 is a change, a slope of -1. Now we can use the coordinates to calculate that same slope. So let's move this. Let's remind you about moving the slope triangle down to here by using the coordinates. This coordinate right here, which is 520, and this coordinate right here, which is 1213. So 520 and 1213. Now 1213 is the point you're going to end at. And this point here, 5, the x value is 5, the y coordinate is 20. This is where we started. So what we're going to do is subtract from where we ended, subtract where we started from where we ended. Sorry about that. So we're going to subtract the coordinates here where we start from the coordinates where we end, which is right here. It's going to move the slope triangle down to here. The reason you want to do that then is you can just read these coordinates to get the change in y and to get the change in x. So remember, it's this point that we're going to move to the origin, because we want to get this side, the horizontal side, along the horizontal axis right here. All right, so this point right here is 13 units along the y-axis. It's this 13 right here. And I'm going to subtract the 20 units. That's going to drop this slope triangle down to the x-axis. So it's going to move this to -7. So we're sliding this down 20 units. And so this is at 13, so this is going to slide down to -7. So that's that 13 minus 20 is -7. So that tells you that this change is -7. If it's too much to count, you can do this by calculating. And then we're going to subtract the horizontal units to move this point to the origin. So we're going to subtract these 5 units right here from 12. So 12 right here, this 12 minus this 5 is going to slide this over to the y-axis. Slide this point from here over to the y-axis. So it slides this triangle over. So this length now is +7 units. You calculate that by doing that subtraction. This length is a -7 units. So you calculate that change by finding that difference, doing that subtraction. And the ratio of the change in the y direction compared to the change in the x direction is the slope. So again, it confirms this counting, but now we're just doing it by calculating. Say these values were huge, too much to just count on a grid. Maybe they were not even on a grid. They're just telling you. Then you can do that by this calculation if they just give you the coordinates. All right. So now we can write the equation, y equals mx+ b. We know now that the slope is -1. We've confirmed that. And where does it cross the y-axis? It crosses the y-axis right up here at 25. So the length is equal to the opposite value of the width plus 25 units. So -1 times the width plus 25. And we have looked at this form before. So we started here, y width plus length equals 25 units. And so if you change the width to x and the length to y, x plus y equals 25. So the y-intercept equals 25, and the slope equals -1. So we've looked at this kind of equation just a moment ago, and we're going to work more with that kind of equation. But if you have that kind of equation, and that was here, x plus y equals -4, this was activity 2. And here, x plus y equals +3. So notice the slope for this line is -1. -1 here, +1 here, that's a slope of -1. Or a +1 and then a -1. This, oh, I'm sorry, going back the other way. So this is a -1. No, let's go this way. This is +1 over -1. So that's a slope of -1, or a -1 over +1. So that's a slope of -1. Sorry about that. This has a slope of -1. This line has a slope of -1. They just cross the y-axis at different places. And this equation right here, this line right here has a slope of -1. All right, and it says, how does the slope of this line describe how the width changes as the length changes? And remember, those changes, that's what describes or defines the slope. What's along that line, how much does the y direction change compared to the x direction? That's the slope, change in y over change in x. Well, if you change the y value, if I add some units to the y value, which in this case is the width, I'm going to subtract that same amount from the length. So this is going to be a positive amount over a negative amount. So I'm subtracting this same amount from the length. So I'm moving this piece over to here. So if I add this piece to the width, I have to subtract that piece from the length. That's a negative slope. And notice it's the same amount. So shown on the graph, the slope is -1. So for each unit, the width increases. So every time this width increases, whatever number of units, the length decreases by that same amount. Likewise, as the width decreases, if I subtract an amount from the width, the length is going to increase by that same amount. By definition, that's a slope of -1. The change along the y-axis is equal but opposite to the change along the x-axis. So length changes by the additive inverse. They're called additive inverses of each other. Equal amounts but opposite signs. So of the change in the width. Additive inverses, by the way, if you add them together, they equal 0. So a lot going on. We're going to get into this form of the equation a little bit later. But just understanding different forms of equations and what happens in this case to the perimeter of a rectangle, a series of rectangles that all have the same perimeter, what line defines that relationship.